Good morning, sunshines. On this video, I'm just going to go over the front side of this practice quiz. It's a review of old stuff, but it was done before break, so make sure that we talk through it. I'll be using a calculator, and I will be using a periodic table. Going to be helpful to have around. It's all about this concept about Avogadro's number. What's Avogadro's number? It's just the number that's a mole. It's 6.02 times 10 to the 23rd of anything. Could be molecules, could be ions, could be eggs, could be dollars. But we use it a lot for counting atoms and molecules and formula units. So here we have some questions. The following questions are referencing sodium carbonate. We don't know that name yet. Na2CO3. How many oxygen atoms are in one molecule? This is not fancy math. We look at the formula and it tells me that there are 2 sodiums, because that goes to the left, only 1 carbon, but there are 3 oxygens. It's simply 3. How many grams make up 1 mole of sodium carbonate? This is where we have to use the periodic table to figure out how much a mole of each of these substances weigh, and then multiply it by however many of these things we have and add them together. If I have Na, and I have 2 of those, and a C, and 3 oxygens, I look for Na, sodium, is 23. But I have 2 of them, so 23 times 2 is 46 grams. Carbon is 12. I know it's 12.01. It's okay to round on those ones. 12 grams. And oxygen is 16 grams. Since I have 3 oxygens, 3 times 16 is 48. Add them all together, you're going to get 106 grams. It's okay if you have more decimals, but it's also okay if you don't. So then how many molecules? Next one. So what is that? 106 grams per mole. That's how much 1 mole would weigh. How many molecules are in 1 mole of sodium carbonate? This is a trick question. It doesn't matter how whatever this substance is or however much it weighs. If we're asking how many molecules are in 1 mole, it is 6.02 times 10 to the 23rd molecules of Na2CO3. How many oxygen atoms are in 1 mole of sodium carbonate? If we have 1 mole of sodium carbonate times 1, and every 1, let's see where we're at here. I need moles of sodium carbonate. How did I know to start? Well, that's the only thing that was given. My given was 1 mole. I know I have to have 1 mole of Na2CO3 down here, so it'll cross off. Moles and moles. So what do I know about a mole? Well, a mole of anything is 6.0 times 10 to the 23rd. These happen to be, we'll call them molecules. They're technically formula units, MLC. Either way is okay. And let's see, they didn't ask me how many molecules are in a mole. That was the last question. They had asked me how many oxygen atoms. Well, look at the formula. Every one of those Na2CO3s has 3 molecules, 3 atoms of oxygen. In every 1 molecule of Na2CO3, there are 3 oxygen atoms, or atoms of oxygen. So in essence, it's just 6.02 times 10 to the 23rd times 3. That's probably going to be 6.02 times 10 to the, I hit the exponent, the EXP button, 23rd times 3 equals, and this calculator's not going to put it, it's going to be 1.81, because I'm rounding the 1.806 to 1.81 times 10 to the 24th atoms of oxygen. Your calculator probably does a better job of telling it to you. How many moles are in 12 gram sample of FeO? Okay, so we start to put some steps together. Here's what we know. We have 12 grams of FeO. That's a number and a unit and a label. I'm going to write down whatever I'm given. That's going to be where I start. It goes at the top of the fraction. I also know that grams of FeO has got to cross out, so it's going at the bottom. What do I know about FeO in grams? Well, nothing yet, but I can use the periodic table to figure out how much a mole of it weighs. How much does a mole of FeO weigh? I have to look up Fe, 55.8, and oxygen, 16. That looks like a 71.8. 85, whatever that might be. 1 mole of this stuff is 71.85 grams of FeO. Is that what they wanted to know? How many moles? Yep, that is all they wanted to know. 12 divided by 71.85 equals 0.17. I'm just rounding off. 0.67 would round to 0.17 equals 0.17 moles. Look, I was ready to multiply there. This thing that I just did here, I was ready to multiply. How did I know I was done? Well, if grams of iron oxide, FeO, and grams of iron oxide cross off, and it leaves me moles of FeO, and they asked how many moles of FeO, well, then I know I'm done. I use the units, number, unit, label, every step, but I let the units lead, the numbers follow. What's the mass of 0.015 moles of calcium hydroxide, Ca, and 2 OHs? That's 2 O's and 2 H's. Well, start 0.015 moles. Leave that E off, that way I get to abbreviate. CaOH2, number, unit, label. What do I know about those? Well, I'm going to have to do some adding of them up, calcium hydroxide. But I'm going to need 1 mole of that stuff, but I have to figure out how much it weighs. OH, that's got parentheses. What is the mass of? So mass is going to be in grams. If I had grams of CaOH2 up here, this and this would be done. I just need to figure out how much 1 mole of CaOH2 weighs. So let me go find some stuff. Calcium, so over here it's 40. 2 oxygens, 16 plus 16 is 32, so I'm at 72. And I need 2 H's. How come 2 H's? When it was written as CaOH2, that means 2 oxygens, 2 H's, and 1 calcium. So I'm at a 40 plus 32 plus 2. I'm at 74 grams. 74 grams. If I take 74 grams times 0.015, I'm going to get approximately 1.11 grams. You probably didn't round the same, and it's okay. That's going to be calcium hydroxide. That is the mass of 0.015 moles of calcium hydroxide, or CaOH, taken twice. How many silver atoms, it's going to be a big number because atoms are small, are contained in 0.650 grams of silver? Start with what they gave me, 0.650 grams of silver. Get ready to multiply by a fraction. Here's what I know. Grams of silver has to go on the bottom. I will not be able to put atoms on top. I don't know the relationship between grams and atoms. All I can figure out is grams and moles of this. And then I can go moles of silver to atoms of silver. I know that that's, because repetition says, I know that if I have grams up here, it's got to cross off. The only relationship I know are moles. Moles and moles will cross off. And so I've got nothing here. I got no numbers, but the units are leading. What do I know? Well, let's see. A mole of anything is 6.02 times 10 to the 23rd. And then I use the periodic table to go find silver. Silver, Ag. It is. I'm not that good at them yet either. There it is, 107.87. If I put in a 107.87 right there, now I got some number crunching to do. 0.65 times 107.87 times 6.02. I doing this right? Yep. E23. And I'm going to get, darn, now I have to do some counting. I'm going to get 4.22 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 times 10 to the 25 atoms of silver. Does that make sense to me? It doesn't, because I only have a really small amount. 0.65 grams is not even a whole mole. So a mole I would have times 10 to the 23rd. So I'm using logic here that says that just doesn't make sense. Let me just go back and check my facts here. Is this what we started with? Yep, 0.650 grams of silver. Is 107.87 moles of silver. So I think I found an error here. I think I should have this number at the bottom. I looked up how much 1 mole of silver weighs, and it was 107.87. So I need to move that so that it's on the bottom. So just the reality check had me catch my mistake here. I'm going to go back and clear this. 0.650 divided by 107.87 times 6.02 times 10 to the, that's the exponent button, 23rd equals. Now I'm getting a big old number again. Yeah, this is what I expected, a big old number, 3.63, because I'm just rounding that, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 3.63 times 10 to the 21 atoms of Ag. Does that make sense that it's not even times 10 to the 23rd? I think it does. That's such a small number. 0.65 grams isn't even 100th of a mole. And so I think that it does make sense that it's going to be moved over. Finally, on the front side, this is a percent composition type problem. They're only going to ask about one. Well, they're going to ask both. I have a sample that has 9.56 grams of copper sulfate. 6.35 grams of that is copper. What is the percent by mass of the copper and sulfur in this compound? So I've got to look at this and say, okay, if I have 9.56 grams of copper sulfate and 6.35 grams is copper, because that's going to be important because they're going to ask me my percentages of copper. When I subtract that, 9.56 minus 6.35, I'm going to have 3.21 grams of sulfur. I want to know the percent by mass, and that's the mass of copper and sulfur. So I've got copper. How much is copper? 6.35 grams out of the total of 9.56 grams times 100 is copper. Setting up the other one, the other let me just pull this down. This is sulfur, 3.21 grams out of 9.56 grams, because that's my total, times 100. That's going to be sulfur, percent copper. Crunch some numbers. 6.35 divided by 9.56 equals, looks like 66%, which means I'm going to have about 34% sulfur over there. That's side one.